Hello, we are going to learn the first lesson of the matrix today. Rates of change in polynomial functions. The first one we have to learn about is AROC, average rate of change. This is also the secant. The equation for AROC is f at x2 minus f at x1 all over x2 minus x1. Now the second concept we must understand is IROC, instantaneous rate of change, also known as the tangent. The equation for IROC is f at x2 plus h minus f at x1 all over h equals 0.001. It is your path, Neo, to complete the task. You are the one.
Today we're going to do solving linear quantities. You can solve these either by using a graphing calculator or algebraically. You must always state restrictions, make a common denominator, simplify and solve, and factor if necessary. When dealing with the example, x plus 3 over x minus 1 equals 2. To make your equality, subtract 2 from both sides of the equation. So you end up with x plus 3 over x minus 1, subtract 2 equals 0. Now to get a common denominator, multiply the top and bottom of the 2 by x minus 1. I have a common denominator of x minus 1. Now you have to rainbow the 2n to the expression to get x plus 3 over x minus 1 minus 2x minus 2 over x minus 1. Since we have a common denominator of x minus 1, we can cancel the denominator only because we're using an inequality, or an equality. Now we have an expression x plus 3 minus 2x minus 2 equals 0. Now we must get all the numbers on one side and all the x's on the other, and end up with negative x equals negative 5. Now divide both sides by negative 1. To solve your equality is x equals 5. Done. Therefore, x equals 5, and the restriction is x cannot equal 1. Toodles.
Now we're going to learn about solving linear inequalities. This is the same work as inequality, but using smaller, larger, larger but equal, smaller but equal signs. Most operations work fine, but the exceptions are when you are multiplying or dividing by a negative. You must switch the inequality sign. We are going to use 4x minus 9 is larger than 3. To be rid of the 9, we are going to add 9 to both sides, which equals 4x is larger than 12. Now we are going to divide both sides by 4, canceling both 4's on the one side, leaving x, and 12 divided by 4 equals 3. Therefore, x is larger than 3. We can also write the solutions as set notation or a number line. And if it is a closed-in circle, colored in, it means including. But if it is circle, none shall pass. This means that if x is greater than 3, then you solve the original as a single inequality.
Now, for double inequality. For this, you do the same work as a single inequality. So, when you have the equation 3x take away 1 between 11 and 23, you have to add 1 to either side of the equation. And you get 3x in between 12 and 24. You then divide 3 to each side, so you get x. So you get x in the middle, in between 4 and 8. You can also show it as a number line.
Oh, I didn't see you there. Just got back from a Hoth.
Time to learn about solving polynomial inequalities. These are nonlinear versions of inequalities. First, you have to factor if needed, get everything to one side, state the zeros, and use an interval table. For example, when x plus 2, x minus 3, x plus 1 is greater than 0, state your zeros as negative 2, negative 1, and 3. Using these, you can now make your interval table, with the first interval being negative 2 is greater than x, negative 2, bracket x, bracket negative 1, so x is between negative 2 and negative 1, and then x is between negative 1 and negative 3, or negative 1 and 3, sorry. And your last interval as x is greater than 3. Now you sub the numbers into each piece of your equation to get the sign. So in negative 2 greater than x, we can use negative 3. So negative 3 plus 2 is a negative. Negative 3 minus 3 is a negative. And negative 3 plus 1 is a negative, making this sign negative. For the second interval, we can choose negative 1.5. Negative 1.5 plus 2 is positive. Negative 1.5 minus 3 is negative. And negative 1.5 plus 1 is negative, making this sign positive. For the third interval, we can choose 1. 1 plus 2 is positive. 1 minus 3 is positive. Or sorry, 1 minus 3 is negative. And 1 plus 1 is positive, making this sign negative. And finally, x is greater than 3, we can use a large number like 100. 100 plus 2 is positive, 100 minus 3 is positive, and 100 plus 1 is positive, making this interval positive. Therefore, the original is solved for when x is between negative 2 and negative 1.
Hello. Now we're going to factor some polynomials. To factor a cubic or a larger value, use factor theorem to find an a value that makes f at a equals 0. Then, you need to divide it using either synthetic division or a long division. Once you have those, you need to factor. You can use the Bergman technique. It's very quality. You can do quadratic formula. Or, for you old schoolers, the chart method. This should get you a final answer, but if it doesn't bring you down so x has a degree of 1, you'll need to repeat until you get an x of 1. Huh, that was pretty cool, but like, what if I don't want to do math anymore?